Welcome to the first video of section 8.3. Now, you're going to see a lot of similarities between section 8.2 and 8.3. So I want you to pay attention to those because it's going to help you solve your problems as you go through these. Now, in 8.2, we were learning about arithmetic sequences. In 8.3, we're going to learn about geometric series. Now, the basic difference between arithmetic and geometric is within arithmetic you were adding or subtracting a constant to each term to get the next. In geometric, you are multiplying each term to get the next. So that's the main difference right there. And then every other step, every other type of problem, just you replace the d, the constant in there, with r, which is going to be our common ratio. So let's go through. We're going to go through each step like we did in 8.2, except we're going to replace a common difference with a common ratio. So the first thing is tell whether each sequence is geometric. Now, in arithmetic, we just subtracted the first term by the second, or the second term by the first. In geometric, we are just going to take each term and divide it by the previous. So to tell if 12 is, if 6 is multiplied by a constant to get 12, and if 12 is multiplied by a constant to give 20, we just take each term and multiply it by the previous. So we're going to start out, we're going to take 12 divided by 6, and let's see what that ratio is. 12 divided by 6 is 2. Now, if this is geometric, we should get that same value for our next one. So now we take 20 and divide it by 12. Nope, we get 5 over 3. So right there we know that these are not constant. So we can go through and check the rest. 30 over 20 is not. 42 divided by 30 is not. So again, once you get this second one and they're not equal, you know that these are not geometric. Here we're looking at ratios, taking each term, dividing it by the one before it. So this first sequence is not geometric because the ratios are not constant. Now let's try our next. So remember our same steps. We take each term and divide it by the one before it. So 64 over 256, we get 1/4. We take A2, divide it by A1. Now let's move on. Let's take A3 divided by A2. So our third term divided by our second. Hey, we get 1/4. So far we're looking good. Let's take our fourth term divided by our third. 4 over 16, 1/4. Looking real good so far. Let's take our fifth term divided by the fourth. 1/4. So now that we've confirmed that this is a constant ratio between each term and the next one, we can say that yes, the ratio is 1/4, so the sequence is geometric. Now, this is pretty simple. What I want you guys to do right here, I want you to, for these three problems, tell whether each sequence is geometric. So you've got three problems here. You're going to answer them all in the same answer box. So label yours 1, 2, and 3. Now, what I want you to do is, remember, when we find if a sequence is geometric or not, we also find what the ratio is. We say that's r. Our ratio is r. So in this case, it would be r equals 1/4. For your answers, what I want you to do for 1, 2, and 3, if the sequence is geometric, I want you to answer, you say yes, and then the ratio is, so r equals, and tell me what the ratio is. So for your answers, you should have the first part of your answer should be yes or no. And if you answer yes, tell me what r equals. So yes, r equals what? Go ahead and take the time to answer this now. All right, for our next part, what we're going to look at is, just like we did in arithmetic sequences, is we want to go ahead and we want to figure out how we can write an nth term rule for each of these. So we're looking at these sequences. Now, each of these is geometric. So you can see right here that in this first term, we have 15 over 5, 45 over 15, and 135 over 45. So in our first one, we know that r equals 3. Now, first, before we get started on these, I want to show you what one of our core concepts is. So with arithmetic, we had our nth term formula, which was a1 plus n minus 1 times d. Now, our geometric formula is different. So here's our geometric formula, our nth term formula for a geometric series. So it's a little different. Right here, I want you to notice our nth term formula is just a sub 1 times r to the n minus 1 power. You should be writing this down in your notes right now. The nth term formula, a sub n, is equal to a1 times r to the n minus 1 power. Remember your order of operations. This is r to the n minus 1 power first, then you multiply that whole number by a sub 1. So let's look at an example of that right now. So if we look at, let's look at this example. If we have a first term of 2 and a common ratio of 3, you would just replace those values. So 2 times 3 to the n minus 1. This is really important to remember your order of operations. A lot of people make the mistake and they just get 6 to the n minus 1 power. Do not do that. That is a common mistake. By this point, you guys know that 3 to the n minus 1 power, then times 2. So you should have this nth term formula written down. Let's look back at our problems. We want to write a rule for the nth term of our sequence. Then after that, we want to find the 8th term in our sequence. So let's look at our first steps. Now, as I was saying here, we know how to figure out our ratio, and our ratio is r. So the first thing we need to do is figure out the terms that we need to write our nth term formula. So your general rule, you always want to write this down first. Your general rule is the nth term formula equals a sub 1 times r to the n minus 1 power. So we know our ratio is 3 by just taking a term and dividing it by the one before it. So r equals 3, and our first term right here, first term is 5. So we simply take those, we substitute for a1, and we substitute for r. So we get 5 equals 3 to the n minus 1 power. So our nth term formula is 5 times 3 to the n minus 1. To figure out our 8th term, we just substitute. For n, we put in 8. So we get 8 minus 1 is 7. We get 3 to the 7th, which is a big number, and multiply that by 5. Now, you're going to notice in geometric series, we end up with some rather large numbers. Remember, this is an exponential function. So we're taking numbers and taking them to large exponents. So as our term numbers get high, we're going to end up with some pretty big numbers here. So don't be surprised if you end up with some large numbers, and don't think you did something wrong. Okay, so that's the first one. Let's do one more example here before I give you some problems. So we've got our geometric sequence right here. So let's do that again. So we know that our first term is 88 right here, and to figure out r, we just take one term and divide it by the previous. So here we take our second term divided by the first, so we get r equals -1/2. So to get our nth term formula, we just write out our general rule. Again, a1 times r to the n minus 1 power is our nth term rule. Substitute a1 and r. Now, this negative number should make sense to you. You see that our numbers are decreasing here. And you also see that the sign is alternating. So that's what happens when you have a negative r value. Let's go ahead and plug in our values. So 88 for a1, r equals -1/2. We go ahead And if we want to figure out the 8th term, we just simply take 8 and plug it into our formula. So we get -1/2 to the 7th power, that's 8 minus 1, multiplied by 88. We get -11/16. Now again, this number shouldn't surprise you because it's a pretty small number. And we notice with our sequence, we're dividing by 1/2 each time. We're taking 1/2 to a larger and larger power. So we start decreasing at an exponential rate. So as you're going through this, make sure that your answers make sense. Start thinking about what, how big of a term you're trying to find, what your ratio is, and you want to see if your numbers do make sense. If you get something that doesn't make sense, go back and check your work. So what I want you guys to do for yours, you're just going to have one example right here, and it's going to be writing a rule for the nth term of a sequence. So you've got your sequence right here. Now, when you write your nth term rule, I know that you're going to have terms and you're going to have some exponents here with like an n-1 power. Okay, make sure that you're clear when you write this out. Okay, write out an equals, and then be clear when you write your base, put parentheses around it, use the little caret, the shift 6 to show me that it's a exponent, and make sure that you write this by itself and then separate the 9th term, a sub 9, so I can see this clearly, so that when I'm looking through and making sure you have the right answers, it's clear what your rule is and it's clear what a9 is. Okay, we want to make sure that you're being clear and nice when you're writing out your answers. So again, your problem in the text box, write a rule for the nth term of this sequence and then find a9.